Troubleshooting LVM. You can use logical volume manager LVM tools to troubleshoot a variety of issues in LVM volumes and groups. Gathering diagnostic data on LVM. If an LVM command is not working as expected, you can gather diagnostics in the following ways. Procedure. Use the following methods to gather different kinds of diagnostic data. Add the -v argument to any LVM command to increase the verbosity level of the command output. Verbosity can be further increased by adding additional V's. A maximum of 4 such V's is allowed. For example, -v. In the log section of the etc lvm.conf configuration file, increase the value of the level option. This causes LVM to provide more details in the system log. If the problem is related to the logical volume activation, enable LVM to log messages during the activation. Set the activation is equal to one option in the log section of the etc lvm.conf configuration file. Execute the LVM command with the -vv option. Examine the command output. Reset the activation option to 0. If you do not reset the option to 0, the system might become unresponsive during low memory situations. Display an information dump for diagnostic purposes LVM dump. Display additional system information LVS-V, PVS-all, DM setup info columns. Examine the last backup of the LVM metadata in the etc LVM backup directory and archived versions in the etc LVM archive directory. Check the current configuration information LVM config. Check the /run/hints/LVM/hints cache file for a record for which devices have physical volumes on them. Additional resources LVM dump man page on your system. Display an information dump for diagnostic purposes LVM dump. Creating dump directory /root/LVM dump server a.example.com 2025 0609 20 2109. Gathering LVM and device mapper version info, gathering DM setup info, gathering process info, gathering console messages, gathering /etc/LVM info, gathering /save listing, gathering /sys/block listing, creating report tarball in the /root/lump dvm lvm dump server a.example.com 2025 0609 2021 09.tgz. Display additional system info LVS-V. /root/. So the dump file is created here. LVM dump file. Display additional system information. LVS hyphen VVVV also I can give. For more information. LVS hyphen V. LVS hyphen VVVV. VVS hyphen all. Physical volume hyphen all. DM setup info hyphen columns. 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 Examine the last backup of the LVM metadata in the etc LVM backup directory and archive versions in the etc LVM archive directory. Examine the last backup of the LVM metadata. Examine the last backup of the LVM metadata in the etc LVM backup directory. ls etc last backup of the LVM metadata in the etc LVM backup directory. ls-l etc backup directory and the archived versions in the etc LVM archive directory. Check the current configuration information LVM config. LVM config. Check the current configuration information using LVM config. Check the run LVM/run/LVM/hints cache file for a record of which devices have physical volumes on them. Which devices have physical volumes on them. ls/run/hints LVM run LVM hints run LVM hints file. So all these devices have physical volumes on them and their respective volume groups is also mentioned here. /run/lvm/hints cache file for a record of which devices have physical volumes on them. Additional resources LVM dump man page on your system. Displaying information about failed LVM devices. Troubleshooting information about a failed logical volume manager LVM volume can help you determine the reason of the failure. You can check the following examples of the most common LVM volume failures. Failed volume groups. In this example, one of the devices that made up the volume group, myVG, failed. The volume group usability then depends on the type of failure. For example, the volume group is still usable if RAID volumes are also involved. You can also see information about the failed device, VGS-options plus devices. So VGS-options plus devices. VGS-options plus devices. Failed logical volume. In this example, one of the devices failed This can be reason for the logical volume in the volume group to fail. The command output shows the failed logical volumes LBS all options plus devices. In this example, one of the devices failed. This can be reason for the logical volume in the volume group to fail. The command output shows the failed logical volumes LBS all, LBS all options plus devices. LVS all options plus devices. LVVG ATTR L size pole origin data percentage meta percentage move log copy percentage sync convert devices. Failed image of a rate logical volume. The following examples show the command output from the previous and LVS utilities when an image of a rate logical volume has failed. The following examples show the command output from the previous and LVS utilities when an image of a rate logical volume has failed. The logical volume is still so previous command physical volume volume group format ATTR P size physical volume size physical extents free physical physical volume free space physical volume size and physical volume free space size and available space. LVS options name VG name ATTR size device space my VG LVS A options name VG name ATTR size devices space my VG my underscore VG. LVS options name VG name ATTR size devices space my underscore VG. So if there are any errors, it displays like this: couldn't find device with UUID, couldn't find all devices for LB while checking used and assumed devices, couldn't find all devices for LB my VG slash my underscore 8 underscore R meta underscore while checking used and assumed devices. Removing lost LVM physical volumes from a volume group. If a physical volume fails, you can activate the remaining physical volumes in the volume group and remove all the logical volumes that use the physical volume from the volume group. Activate the remaining physical volumes in the volume group. VG change activate y partial space by VG. Check which logical volumes will be removed. VG reduce hyphen hyphen remove missing hyphen hyphen test space my VG. Remove all logical volumes that use the last physical volume from the volume group. VG reduce hyphen hyphen remove missing hyphen hyphen force my VG. Optional, if you accidentally remove logical volumes that you wanted to keep, you can reverse the VG reduce operation. VG CFG restore space my VG. So removing last LVM physical volumes from a volume group. If a physical volume fails, you can activate the remaining physical volumes in the volume group and remove all the logical volumes that use that physical volume from the volume group. Activate the remaining physical volumes in the volume group. VG change hyphen activate. VG change hyphen activate Y hyphen partial space my underscore VG. 9 logical volumes in volume group my underscore VG now active. Incomplete partial mode incomplete logical volumes will be processed. Incomplete logical volumes will be processed. Check which logical volumes will be removed. VG reduce hyphen remove missing hyphen test space my VG. VG reduce hyphen remove missing hyphen test space my underscore VG. Test mode metadata will not be updated and volumes will not be activated, deactivated or activated. Volume group my underscore VG is already consistent. So VG change hyphen activate by hyphen partial my underscore VG. VG reduce hyphen remove missing hyphen test my underscore VG. So VG reduce hyphen remove missing hyphen force space my VG. Remove all the logical volumes that use the last physical volume from the volume group. So remove all the logical volumes that use the last physical volume from the volume group. VG reduce remove missing hyphen force space my underscore VG. Volume group my underscore VG is already consistent. Here it is consistent. Optional, if you accidentally removed logical volumes that you wanted to keep, if you accidentally removed logical volumes that you wanted to keep, you can reverse the VG reduce operation. VG CFG restore space my VG. VG CFG restore my underscore VG. Do you want to really proceed with the restore of volume group my underscore VG with 59 while 59 volumes are active? Yes, restored volume group my underscore VG. Warning, if you remove a thin pool, LVM cannot reverse the operation. If you remove a thin pool, LVM cannot reverse the operation. Finding the metadata of a missing LVM physical volume. If the volume group's metadata area of a physical volume is accidentally overwritten or otherwise destroyed, you get an error message indicating that the metadata area is incorrect or that the system was unable to find a physical volume with a particular UUID. This procedure finds the latest archived metadata of a physical volume that is missing or corrupted. So if the volume group's metadata area of a physical volume is accidentally overwritten or otherwise destroyed, you get an error message indicating that the metadata area is incorrect or that the system was unable to find a physical volume with a particular UUID. This procedure finds the latest archived metadata of a physical volume that is missing or corrupted. Procedure find the archived metadata file of the volume group that contains the physical volume. Find the archived metadata file of the volume group that contains the physical volume. The archived metadata files are located in the etc LVM archive volume of group volume-group-name underscore backup-number dot pg path. Volume group name underscore backup number dot pg path. Find the archived metadata file of the volume group that contains the physical volume. Replace 0000-124899998876 with the backup number. Select the last known valid metadata file which has highest number for the volume group. Select the last known valid metadata file which has the highest number for the volume group. So cat etc LVM etc LVM archive that contains the physical volume. Replace this with the backup number. Select the last known valid metadata file which has highest number for the volume group. Highest number for the volume group is this one, 5, 8, find the UUID of the physical volume. Use one of the following methods. List the logical volumes LBS all options plus devices. Find the UUID of the physical volume. Use one of the following methods LBS all options plus devices. Examine the archived metadata file. Find the UUID as the value labeled ID is equal to in the physical underscore volume section of the volume group configuration. Find the UUID of the physical volume. Use one of the following methods. So the UUID is present here. The ID so R image, R meta. It contains only R image and R meta. Okay, test 1, read 1A. The ID, status, read write visible flags, creation time, creation of segment count, segment 1, start extent count, type is RAID 1, device count 2, region size 4096 rates. Test RAID 1 A R meta underscore 0, R image underscore 0, test RAID 1 A, R meta underscore 1, R image underscore 1. So list the logical volumes LBS hyphen hyphen all hyphen hyphen options plus devices. List the logical volumes. Find the UUID of the physical volume. Use one of the following methods. List the logical volumes. Examine the archived metadata file. Find the UUID as the value labeled ID is equal to. So this ID, this one. Deactivate the volume group using the partial option BG activate VG change hyphen activate space and hyphen partial space my underscore VG. VG change hyphen activate N partial space my underscore VG. So incomplete logical volume will be processed. Zero logical volumes in the volume group my underscore VG now active. So all have become inactive. All the logical volumes in the volume group my underscore data has become inactive. Restoring metadata on an LVM physical volume. This procedure restores metadata on a physical volume that is either corrupted or replaced with a new device. You might be able to recover the data from the physical volume by rewriting the metadata area on the physical volume. Warning, do not attempt this procedure on a working LVM logical volume. You will lose your data if you specify the incorrect UUID. Prerequisites: you have identified the metadata of the missing physical volume. For example, see finding the metadata of the missing LVM physical volume. Restore the metadata on the physical volume. PV create hyphen UUID physical volume UUID hyphen restore file etc LVM archive volume group name backup number.vg. Block device. So PV create hyphen UUID physical volume UUID backslash hyphen restore file etc LVM archive volume group name underscore backup hyphen number dot vg slash block device. The command overrides only the LVM metadata areas and does not affect the existing data areas. Restoring a physical volume on slash type slash VDB1. The following example labels the slash type slash VDB1 device as a physical volume with the following properties. So PV create hyphen FF hyphen UUID. I have given the UUID in the restore file etclvm archive myvg00558 hyphen 124.958.149.1.vg slash type slash sta. So really initialize physical volume slash type slash sta of volume group my underscore vg. I'm giving yes. So physical volume slash type slash sta successfully created. Forcing physical volume creation on slash type slash sta volume group my underscore vg. and then restore the metadata of the volume group. VGCFG restore my VG. VGCFG restore space my underscore VG. So restored group volume group my underscore VG. Restored volume group my underscore VG. Display the logical volumes on the volume group. LVS hyphen hyphen all hyphen hyphen options plus devices space my underscore VG. LVS hyphen hyphen all hyphen hyphen options plus devices my underscore VG. The logical volumes are currently inactive. If the segment change of the segment type of the logical volume is read, resynchronize the logical volumes. LV change hyphen hyphen resync my VG slash my LV. LV change hyphen hyphen resync my VG's my underscore VG slash logical volume name. Activate the logical volume. Shall we change hyphen hyphen activate Y my underscore VG slash my underscore LV. LV change hyphen hyphen activate Y First resync and then activate. If the on-disk LVM metadata takes at least as much space as what overrode it, this procedure can recover the physical volume. If what overrode the metadata went past the metadata area, the data on the volume may have been affected. You might be able to use the fseek command to recover that data. Display the active logical volumes LVS-all options plus devices. LVS-all options plus devices. Rounding errors in LVM output. LVM commands that report the space usage in volume groups round the reported number to two decimal places to provide reported number to two decimal places to provide human readable output. This includes the VG display and VGS utilities. As a result of the rounding, the reported value of free space might be larger than what the physical extents on the volume group provide. If you attempt to create a logical volume the size of the reported free space, you might get the following errors. Insufficient free extents. To work around the error, you must examine the number of free physical extents on the volume group, which is the accurate value of free space. You can then use the number of extents to create the logical volume successfully. Preventing the rounding error when creating an LVM volume. When creating an LVM logical volume, you can specify the number of logical extents of the logical volume to avoid rounding error. Find the number of free physical extents in the volume group. VG display my VG. VG display my VG. VG display space my underscore VG. So total P is 7154. The following volume group has 8780 free physical extents. Create the logical volume. Enter the volume size in extents rather than bytes. Enter the volume size in extents. Enter the volume size in extents rather than bytes. Creating a logical volume by specifying the number of extents. LV create extents 8780 name is my LV my VG. LV create extents. I'm giving only 10 extents name. So 40 MIB. My LV1 in my underscore VG. Creating a logical volume to occupy all the remaining space. Alternatively, you can extend the logical volume to use a percentage of the remaining free space in the volume group. For example, LV create extends 100% free. Hyphen name my LV space my VG VGS. So LV create hyphen extends 100% free hyphen name my LV to in the volume group all group tag which is extends. So logical volume my LV2 created. See, you can see zero space is available in the volume wall group tag volume group. It is completely occupied by logical volume. So the size of the logical volume is my LV2 is 1.99 GB, 100% free. Hyphen space my LV my VG. Check the number of extents that the volume group now uses. VGS hyphen options plus VG underscore free underscore count comma VG underscore extent underscore count. VGS hyphen options VG free count. VG free count comma VG extent count. VG free count comma VG extent count. VGS hyphen options plus VG underscore free underscore count comma VG extent count. Check the number of extents that the volume group now uses. LVM metadata and their location on disk. LVM metadata and their location on disk. LVM headers and metadata areas are available in different offsets and sizes. The default LVM disk header is found in label underscore header and PV underscore header structures. Is in the second 512 byte sector of the disk. Note that if a non-default location was specified when creating the physical volume PV, the header can also be in the first or third sector. The standard LVM metadata area begins 4096 bytes from the start of the disk. Hence, one MIB from the start of the disk begins with a 512 byte sector containing the MD underscore header structure. A metadata text area begins after the MD underscore header sector and goes to the end of the metadata area. LVM VG metadata text is written in a circular fashion into the metadata text area. The MD underscore header points to the location of the latest VG metadata within the text area. You can print LVM headers from a disk by using the pvc-dump header /tab/sta command. This command prints the label underscore header, PV underscore header, MD underscore header, and the location of the metadata text is found. Bad fields are printed with the check prefix. The LVM metadata are offset will match the page size of the machine that created the PB. So the metadata area can also begin 8K, 16K or 64K from the start of the disk. Larger or smaller metadata areas can be specified when creating the PB, in which case the metadata area may end at locations other than 1 MIB. The PB underscore header specifies the size of the metadata area. When creating a PB, a second metadata area can be optionally enabled at the end of the disk. The PB underscore header contains the locations of the metadata areas. So PVCK hyphen dump headers slash save slash STA. So it has all these headers, label underscore header, PV underscore header, and MD underscore header. Extracting VG metadata from a disk. Choose one of the following procedures to extract VG metadata from a disk, depending on your situation. For more information about how to save extracted metadata, see saving extracted metadata to a file. Note: for repair, you can use backup files in etc LVM backup without extracting metadata from the disk. You can use backup files from the etc LVM backup location. Print current metadata text as reference from valid MD underscore header. Print current metadata text as reference from valid MD underscore header. PVC hyphen metadata space disk. Metadata text from valid MD underscore header. PVC hyphen dump metadata slash save slash STA. So PV sync hyphen dump metadata slash save slash STB. Print the locations of all metadata copies found in the metadata area based on finding a valid MD underscore header. Print the locations of all metadata copies found in the metadata area based on finding a valid MD underscore header. PVC hyphen dump metadata underscore all space disk. pvc-dump metadata underscore all space disk slash sta. So pvc-dump metadata underscore all space slash sta. Locations of metadata copies in the metadata area. Search for all copies of metadata in the metadata area without using an MD underscore header. For example, if headers are missing or damaged. Search for all copies of metadata in the metadata area without using an MD underscore header. For example, if headers are missing or damaged, pvc-dump metadata underscore search space disk slash sta. Copies of metadata in the metadata area without using an copies of metadata in the metadata area without using an MD underscore header. Copies of metadata in the metadata area without using an MD header. pvc-metadata underscore search slash stb. pvc-dump metadata underscore search slash stb. Dump metadata underscore search slash sta. Include the -v option in the dump command to show the description from each copy of metadata. Include the -v option in the dump command to show the description from each copy of metadata. pvc-dump pvc-dump metadata -v slash sta. Showing description from each copy of metadata. pvc-dump metadata -v slash stb. This file can be used for repair. The first metadata area is used by default for dump metadata. If the disk has a second metadata area at the end of the disk, you can use the -hyphen settings and double quote md underscore num is equal to 2 option to use the second metadata area for dump metadata instead. This file can be used for repair. The first metadata area is used by default for dump metadata. If the disk has a second metadata area at the end of the disk, you can use the -hyphen settings in double quote md underscore num is equal to 2 option to use the second metadata area for dump metadata instead. -hyphen settings mda underscore num is equal to 2. Saving extracted metadata to file. If you need to use dumped metadata for repair, it is required to save extracted metadata to a file with the -f option and the -f settings option. Procedure: if -f angle bracket file name is added to the -f dump metadata, the raw metadata is returned to the named file. You can use this file for repair. If -f file name is added to the -f dump metadata underscore all or -f dump metadata underscore search, then raw metadata from all locations is returned to the named file. To save one instance of metadata text from -f dump metadata underscore all or metadata underscore search, add -f settings double quote metadata underscore offset is equal to angle bracket offset, where offset is from the listing output metadata offset. Output of the command pvc-f dump metadata underscore search -f settings metadata underscore offset is equal to 5632 -f meta.txt //stb pvck-dump metadata underscore search -settings metadata underscore offset is equal to 5632 -f meta.txt //sta. Metadata at the 5632 length. Offset, I will change the offset. So let me see the meta.txt file. 0 bytes in size.